All right. Well, I'm really flattered and amazed by the turnout here. We've got standing room only, so thank you guys all for coming to this session. This is my first time presenting at ChefConf, although Michael Noring, our CEO, was here last year, I believe. Topic for today is operationalizing other people's poorly deployed cloud deployments, or as I like to put it, migrate in haste, repent at leisure. This is born out of a lot of experience we've had doing enterprise cloud migrations and systems architecture projects over the years. But why? Why should you believe me or us about what we have to say? First thing is we don't sell things, so we're not here to resell or convince you to buy product of any sort. We actually only do professional and managed services. That's the only way we make money. We're vendor neutral, so we have companies like Chef that we like and that we work with and that we support, but we are not beholden to them, and when we think that they're doing something wrong, we are quick to point it out to them and our clients. We've been around for 11 years. We started out doing P2V virtualized data center migrations, data center build-outs, early kind of pre-Chef, pre-Puppet, bash scripting and deployment automation back before there was such a thing. And most of us came out of the ISP and backbone and enterprise software world. One of the things that I think is kind of fun about us, we're not a huge company, but we're big enough that we've made premier status with 2 of the 3 major cloud providers, Google and Amazon Web Services. And I believe we are the only boutique consulting and professional services firm that is in the premier consulting category with them. All of the others are mega companies like Accenture and Capgemini and whatever else. Okay, so me, I started Cascadeo about 11 years ago after lots of time in the ISP and hosting and backbone community. Built one of the first dial-up ISPs, DSL ISPs in Seattle. Did a bunch of ISP mergers and acquisitions and learned a lot about other people's deployments through the process of consolidating these 8 or 9 different ISPs that we acquired with all their legacy systems that had been built by hand. And a lot of the people that had built them, of course, were gone. I also worked on Silicon Valley. Some of you guys probably have seen that show. It's kind of a fun show. If you remember in season 2, there was a whole bit with data center in the garage and Bitcoin mining rigs for servers. That was my idea and contribution to the project. Also was heavily involved with the Seattle Internet Exchange, which is a public Ethernet switch in Seattle that is the world's largest free exchange point. We move almost a terabit per second of backbone traffic now across the 6. And I was one of the founding board members of that and have been involved with that for quite some time. Also built the distributed telemetry system for one of the cloud platforms behind the scenes. So we do work not just for clients, but also for some of the providers. And of course, it's Chef-based, so definitely appropriate. Also went to UW for undergrad and graduate. Used to fly airplanes. Then I had kids. Decided that was not a good idea anymore, but I still like to travel and ski. So airplane days are done, but still try to ski as much as I can. The picture, by the way, at the top is my youngest, Oliver, and on the bottom is me eating a gigantic maggot in the Amazon many years ago whilst traveling. So, awful. It was revolting. The head was crunchy, so the body was squishy, and then when you bit it was one of the worst things I've ever done. But I did it, and I'm here to tell the story, right? Okay, so like I said, we've been recognized by a bunch of these companies as not boneheads. We also are big fans of whale sharks. You might see some of these popping up from time to time, and that's an inside joke that some of you probably will find out about someday. But by no means do we only do these things. These are just companies that we end up working with a lot because they tend to be big players in the industry, and ultimately we're demand-driven, right? We're going to follow where customers want us to go because we're consultants and they pay us to do stuff. So. Okay, enough marketing stuff. I'm not going to babble on about Cascadeo or about what we do until I give you a demo of our product, which has never been publicly seen before at the end of this. What I want to talk to you about today instead is the hell that is other people's stuff, right? So, when you inherit somebody else's environment, either at your job or at a new job or because you're a hosting provider or an MSP, how do you rationalize that and take control of it and have some sense of predictability around it when half the time it wasn't even documented and it was built by hand years ago and the people who built it are long gone, right? So it was really easy when we started out doing this, and I'll say that as about 10 years ago. We used to always have this conversation with clients, what are you trying to do? and what are your parameters, right? Because we can do it really fast if we throw a lot of bodies at it, and if we pick the right bodies, we can do it fast and we can get it right, but that gets expensive. And if you want to go hire a bunch of just sort of random bodies to fill seats, that might be cheaper on a per unit basis, but it might take longer and the correctness factor might go down. So pick any two, right? Which of those two do you want? And that used to work. People used to be willing to accept that as a reasonable compromise because everybody else told them the same thing. That was just the reality of the market. Today, I think it's gotten better, in part because of good tech like Chef, and in part just because expectations from consumers have changed. I think durability has gotten really good, and by durability I mean we're not going to lose people's data. That almost never happens unless you're really, really bad at your job, or you have some horrible, inside sabotage scenario, I guess. Moderately high availability, so I think we've gotten to the point where even legacy vertical ERP apps can be built and operated in a way that keeps them fairly stable and reliable, although, as was mentioned in the keynote this morning, there's this culture of sort of fear and paralysis around change management and around operations because the consequences of screwing these big monolithic systems up are so bad, right? If you knock the one mainframe at United Airlines offline, you've just stranded a bazillion people and you've cost the company $100 million, right? No one wants to be that guy. Or the person at Amazon who took down S3 for that matter. Sorry, I don't mean to pick on them, but I've done it. I haven't taken down S3, but I've done some dumb things, of which you'll see soon, actually. And then scalability. So we've gotten pretty good at building scalable systems, but usually you get, kind of two of the three. You don't really get all three. The problem is customers, and I'm not talking about the people that pay me. I'm talking about the people that pay our customers. Their expectations have changed dramatically, right? And I'm going to use Facebook as a good example, but it's by no means the only one. Customers view this as, first and foremost, theirs. It's no longer your data. It's no longer your company's data. In their minds, those cute pictures of their kids on a tricycle belong to them, even though licensing-wise, maybe they belong to Facebook. They always want to be able to get those pictures, no matter where they are. They want to show their mom, their grandma, whenever, wherever. They don't want the system to be slow. They don't want it to go down. They want it to work all the time. They don't want you to leak their personal photo library. They don't want you to lose them. They expect all of this stuff to just work automatically, and when it doesn't work, they get really, really upset. If you're trying to share some cute kid pic with grandma and it doesn't work, or you're trying to FaceTime with grandma and it doesn't work, it's a incredibly upsetting and frustrating experience, especially to non-technical users, right? And the reality is that the majority of the consumers in the world are not very technical, and if you explain to them, well, there was this, that, and the other, and I lost your data, they don't hear this, that, and the other. They hear, what do you mean you lost it, right? So I think we're in a really challenging spot where the implicit assumption that customers carry into a transaction with any kind of a vendor these days is that they're going to get all of this stuff right all the time. So what do companies do in practice? This is my oldest. This is Isaac. Isaac getting into the pool for the first time. Just decided to just jump right in and see how he liked it. And I would say this pretty much sums up lift and shift in my mind. So lift and shift, for those unfamiliar, means taking some VM or server that has been running and somehow moving it over into some other person's environment or company's environment and hitting go and maybe playing with some knobs and levers to get it to work, and then it works, and that's considered done. And I posit that this leads to that scenario, even though it's not quite as instantaneous. He realized instantly that jumping in the pool was probably not going to work out the way that he thought it would. Most people that lift and shift and get it to work run in that state for some period of time before the real misery begins. Why is this a bad idea? Okay, so you guys are all sort of chef nerds, so I think you probably know a lot of this already, but I'm going to quickly tick through it just to make sure that we've covered it. First and foremost, if you have machines that humans build and maintain by hand, over time, they get crufty. Stuff piles up, versions get layered on top of versions, and your ability to accurately describe the state of that system or recreate it at any given time is massively impaired. Couple that with all of the recent revelations, courtesy of Snowden and others, about the extent to which not just the quote-unquote bad guys, but the good guys are mass deploying malware and rootkits, even at the hardware level. I think when you have VMs that have an unknown operational history and have been running for months or years, the odds of them becoming compromised in a way that you're never going to find barring network traffic analysis. I think that goes way up. So I think short-lived VMs trump long ones, if only because there's less cruft and there's less time elapsed from when a compromise occurs to when it's hopefully factored out. But bigger than that, I think, is that a lack of repeatability means that when you need it most, you may not be able to recover, right? I think we all have been through enough operational experience to know that in the real world, DRBC plans exist on paper. They get exercised infrequently and imperfectly, if at all. Sometimes those exercises are not a full failover and failback. They're just sort of a dry run or dress rehearsal. And a lot of companies will say things like, well, it's okay because we have a snapshot, and if things break, we can just roll back to the snapshot, which is great right up until that doesn't fix the problem, right? So many times people say, well, we'll just roll back, but then the bug resurfaces, and they're like, well, it wasn't here before. That doesn't matter. It doesn't matter if it was there before. Just having a snapshot is not enough to recreate the system state to a known quantifiable objective, right? And then the last one, Band-Aids become fossils, right? If you have humans in there applying bandages under the gun at 2 in the morning on New Year's, no one's going to go back and fix those things and clean them up. And sooner or later, someone's going to forget, and then something's going to break, and you're going to go through that whole cycle again. You're going to take a second incident of a human trying to figure out fundamentally why it's broken rather than letting it heal itself. So it's even worse than this because, and again, we're friends with a lot of the cloud providers, but we do not represent them or their interests. They want you to do lift and shift, by and large, because it accelerates revenue for them, right? So if you move VMs into their cloud environments and hit go, the meter starts spinning, revenue numbers go up, Wall Street smiles, everybody wins, except, I would argue, the customer. There are corner cases where lift and shift is not evil, but those are carefully considered and, I think, thoughtful decisions, as opposed to using lift and shift by default, which is what we see in the field a lot of companies doing. A lot of them, you know, their mindset is, let's just get the stuff into the cloud, and then we'll come back and automate it later. I would argue, having been through a lot of these now, at kind of all stages of the public cloud era and the stuff managed hosting that came before it, it turns out that even though it sounds like it would be easier to run a VM through a converter and maybe make some tweaks to it, you often end up spending more time and energy dealing with driver issues or volume replication issues or whatever it may be. And it ends up being the case that even if you had to manually redeploy it, that probably would have been more efficient than just trying to suck the thing into pick your cloud and hit go. And then the last thing, I think, we all know this, there's no such thing as doing it once in the cloud. You're going to get the subnetting wrong, you're going to get the addressing schema wrong, you're going to get a new Amazon account, you're going to get something that's going to necessitate redeploying. Even if you think it's done, it's never done. And if you're going to do it twice, you're going to do it thrice. And if you're going to do it twice or thrice, you might as well just take the time to write some automation around it. And yet, as a managed hosting provider, of which we are one, we're stuck with it, right? Because customers come to us and say, help us, help us. Here's a common scenario. Help us, help us. The guy who moved us into Amazon is gone. There's no documentation. The system is running in production. And the airplane, it's at 30,000 feet, and it's on autopilot, and it's working, but we don't know how much gas it's got, and we don't know where we're at with maintenance. And so, you know, we collectively, and my little company, are stuck with this, right? The cloud providers want it. They are spending buckets of money driving it because, again, they view it as a land grab. They view it as get the customers in, and we'll sort it all out later because whichever cloud they land on, they're going to stick. And most of these companies have already done it, right? A lot of the companies that we interface with are no longer in the thinking about cloud stages. They are in the, we've already got stuff running in production, even though we don't really have it set up correctly. What do we do? This was the case, the last point, when I was an ISP and a web hosting person, and it's certainly the case today, trying to be the ops staff for 1,000 deployments done 1,000 different ways by 1,000 different humans. It's almost impossible, right? These are all one-offs with their own little tweaks, their own little vertical apps, their own little scripts and cron jobs and whatever else. And trying to operationalize that is really, really hard. All right, another painful reality. 100% of everything, including humans like myself, fail in practice, right? If you have anything that runs for a long enough period of time, something horrible will happen. There'll be a fire, there'll be a earthquake, there'll be a nuclear incident, or in this case, If any of you have been to the Philippines, there's a drink called tanduay. I don't know if Chris knows about this. Tanduay is, they call it rum, but I assure you it's not. It's something far, far, far more dangerous. Another thing you got to think about here is scale. So I like to pick on Airbus a little bit. The A380, obviously a miracle of engineering. It's so big, in fact, that they had to make special airplanes just to move the parts to make the A380. And then when they made the A380, they had to widen the taxiways, and they had to put new jetways in, and they had to have a whole new slew of facilities to accommodate something that had scaled beyond what the rest of the industry had decided the natural vertical scaling limit for an aircraft was. It's cool, but boy, that's a really extreme corner case. There's not that many A380s. There's not that many airports that can even accommodate one, and it takes a heck of a lot to fill one of these things up with 700 passengers, right? Now, if you look at Tesla's approach to the Gigafactory and contrast that to the A380, I think it's kind of an interesting thing, right? The A380 is this giant, massive, vertically scaled system that if it blows up, you kill 700 people and cost $1 billion. So you better get it right every single time, right? You cannot afford to have these things fall off the back of the bus. And they all get built by hand, and there's customizations, and the different airlines want different seating configurations, and it's all built to spec. Tesla, if you guys have been watching this, fascinating stuff on the Gigafactory design and how they're doing that. I think key thing here is that they view collectively the Gigafactory as the product. The product is going to be made more than once, so we're not just going to make one of these things, we're going to make lots of them, and we're going to automate the crap out of all of them and iterate on them, and we're going to make lots and lots of batteries and put some of those batteries into cars and power packs. Some of them are going to fail. There's going to be fancy ones, there's going to be cheap ones, but at the end of the day, it's a automation and scale project instead of a let's build the perfect thing that never falls out of the sky and can scale to impossible limits because we can kind of a project, right? Both are cool, but I would argue that the latter is probably more forward-looking from a overall engineering and architecture standpoint. So how do we fix the mess, right? There's all these deployments out there. Customers have already spent money. They're not going to tear them down. My whole company runs on this legacy vertical line of business ERP app. I've moved it into, let's pick on Google today. So it's running on Google Cloud, even though I don't really know how it runs. And I don't really know what's going on, and things just got worse, right? And I think a lot of this has to do with the same fundamental design flaw that led to, this is Fukushima, by the way, but any kind of nuclear incident like this where these systems are built with a fundamentally flawed assumption, and that is that humans will be able to maintain positive control over the system at all times. So Fukushima had triply redundant cooling systems, all active. They had grid power, they had diesel generators, and they made their own power with a nuclear reactor. Turns out that triple redundancy doesn't mean anything if a tsunami comes and wipes it all out, right? So the big problem was they thought that they could maintain operational control, and they baked that assumption into their engineering plan. This is what companies in the non-cloud world do with their IT. They make the assumption implicitly that they can maintain these things and fix them, and that if they fault, that they can come and run fast enough to press the button before the thing melts down. And that sooner or later, 100% of everything sucks given a long enough runtime. So you guys probably already know some or all of this, but I'll quickly recap it because I think these are important. If you're building apps for the cloud or you're refactoring for the cloud, there's always compromises to be had, in no small part because you don't have good visibility or control over the underlying network and systems infrastructure. I think, on the first point, Google has taught us, among others, that good enough really is easier than you think. So think about Gmail. Gmail sometimes will say, whoops, sorry, I can't load your mail right now. Sorry, the UX is still there. Customers don't feel like they're getting a 500 or dead air, but maybe your mailbox is offline for a moment. I think availability is overestimated in most people's minds. I think people assume that they need 5 nines when in reality getting to that is astronomically difficult and expensive. And in reality, if you can preserve the endpoint and the illusion of uptime and availability, even if there are back-end failures, people are much more forgiving and tolerant of that. I think another thing that people often don't fully contemplate and understand is data loss. So they'll say things like, well, if it breaks, we have backups. Okay, so how often do you run your backups? Well, we run them every 12 hours. So do you test them every 12 hours? No. So what happens if the backup is bad? Oh, well, it won't be. Well, okay, let's hope so. So I think if you are willing to write down in set in stone what is your tolerance for data loss and how quickly do you have to be able to recover, you can make a lot of good engineering decisions and trade-offs that other non-technical people can understand about what that means in practice. And I'll give you an example. If the boss says, 0 data loss, absolutely unequivocally not one transaction can be lost, this is Visa and MasterCard and you cannot lose one credit card transaction, that's fine, but that means synchronous data replication, which is very, very expensive to do at scale, right? If you say, hey, look, I'm willing to lose no more than n minutes of data, and I understand the cost of that, and I can prove at all times that that is the worst case outcome that's going to occur no matter what, that's a different scenario. And oftentimes it's much, much less expensive than trying to build a system that never fails, right? I think scalability, obviously running big monolithic vertically scaled apps is not fun. Running lots of parallel production deployments is better with some kind of a traffic management or load balancing tier in front of it. Not all legacy apps can be retrofitted easily to this. The ones that can't, good luck. You just have to live with it, I guess, until they're gone. But many of them you can actually sort of wrap orchestration frameworks around and run multiple copies and shard the workload across them. We've done a lot of this work for extending the life of vertical apps that need to keep running at increasing scale without trying to vertically scale forever. And then security, I'm very much a pessimist. We take the assumption of breach philosophy, which is to say everything is compromised, soup to nuts, including the hardware that you're using right now. We don't even know how many different parties have compromised it. We just know that there's at least one of them, and probably more than one. And so our focus shifts instead to blast radius. So when it occurs, how do we limit the destruction that's inevitable? We don't want your personal iMessage chat history leaked to the internet because that would be absolutely devastating to Apple. So they've gone to great lengths to limit the blast radius if and when iMessage gets compromised to make sure that there's, hopefully, please, never a fappening moment with a bazillion people's iMessage accounts getting dumped to the internet. The real solution to all of this, at the end of the day, is microservices. We define that internally as having 3 components. Interaction layer stuff, this talks to the world, could be API endpoints, could be web endpoints, could be mobile apps. Coordination, so some system that deals with asynchronous event handling, be that polling, be that PubSub, be that just API events coming in, and then a bunch of back-end services. This is usually where we try to relegate legacy applications. So I'll pick on Alaska Airlines, by the way, the best airline in America at this point, if you guys haven't flown them. Alaska Airlines did a magical thing where they took all their legacy airplane, ERP stuff that probably runs on mainframes back here, and they've really done a great job at wrapping their web interface and their mobile user experience and their check-in experience with really good interaction and presentation layer stuff, and the ability over here to deal with transient failures of various forms. So even though I'm guessing on the back end at some ancient system, it doesn't feel like you're using Sabre on American. It feels like you're using a modern, properly designed web app. Another thing we see companies get wrong all the time, almost down the line, almost every single one of them get this wrong, and I don't know why. I think that there's an implicit assumption that if you move stuff to the cloud, that now the network is somebody else's problem. And a lot of these companies also made really bad design assumptions in their systems architecture, like here's the app server and here's the database server, and there's a wire connecting them, or there's a switch between them. And then all of a sudden, they take things like an app server and they move it into the cloud, but leave the database server behind. And now that traffic is going across a wide area network with higher latency. And they can't quite figure out why the app is slow. And it's like, well, So here's the thing, right? Network is more important than ever before, and there's no way to make that somebody else's problem entirely. Things like Meraki, if you guys haven't seen this yet, this is a company Cisco acquired. Fascinating technology. I'm absolutely convinced that's the future of network engineering. And I used to be the BGP guy that got to sit there and feel important and special because I knew it and nobody else did. Meraki is absolutely the right way to go, not because of them as a company, but because of the approach. And the general approach here is they take all of the control plane and config management and analytics stuff, make that a SaaS. They sell you the box, but the box is basically lobotomized and just contacts the cloud mothership to get its configuration data. This lets you do all sorts of things like API integrations. It lets you do things like create templates that get uniformly deployed. You guys have heard this story before. It basically lets you apply good practices in configuration management and deployment automation to your network, which most companies absolutely neglect to do. I can't tell you how many times I find firmware that's 5, 7, 8 years old running on production switches. And I'm like, well, why is this? Well, it's stable. It works. And yeah, I guess that's technically accurate. It is. But what happens when it doesn't? When was the last time that anybody exercised any of their operational process around network failures? It's amazing to me how little attention this gets in practice. All right, so I don't mean to sound all doom and gloom, but a lot of this stuff isn't going to get fixed, right? For one thing, companies have got bazillions of dollars wrapped up in investments that they're not eager to write off. So a lot of them have spent big money on data center, on whatever else. And I feel like all of these problems are just getting worse over time. So how do we solve this? Our attempt, and this is, like I said, the first time that we're going to show this in public, is to build a platform for making this less error-prone and less human-driven. The idea here is to make this as valuable as it can to everybody. We want to deliver these automations first and foremost. We're not interested in pretty UIs and flashy marketing demos. We want to make it so that customers can fire us, so we can leave value behind. We will give you something for free, and you can fire us and keep it. But really what we're trying to do is take all of these painful lessons that we've learned over the years doing this in a consulting basis and in a managed service basis and turn it into something sort of like a SaaS service. So here's the idea. Super, super simple, I think. We have a bunch of stuff, of which Chef is proudly featured, that will colonize customers' existing employment or infrastructure deployments. This could be on-prem, could be cloud. And by doing this, we automatically set up an entire analytics pipeline, alerting pipeline, visualization, et cetera, and we do it using open source software so that the customer can fire us and keep running the stuff and not have to pay us if they don't think we're bringing enough value to the table. So here's an example of telemetry data that's being outputted by the system in Kibana, which many of you probably used. Obvious system metrics, nothing too exciting here, except that all of this can be done now without a human touching anything in an environment that we've never contacted before. We're working really hard on smart auto discovery, so how do we sort of get a beachhead in and then figure out as much as we can about everything as we possibly can, including, and this is a key thing, any existing monitoring or application performance tooling, right? We want to support more cloud providers. Right now, this is really kind of AWS-centric because that's what the market is going after, but we want to make this agnostic. But the real goal here, and I'll get to that in a second, is the analytics angle. So what we really want to do is teach people something that I think 99% of companies have no idea how to actually do in practice, and that is do machine learning on system telemetry, right? So if you can extract, and I learned this because I did this for one of the cloud providers, and it took years to really understand it, but if you can record every single data point about every single thing and feed that into machine learning, you can get way, way, way better at operations. In fact, you can often see things before they go wrong, and you can prevent outages. And I'm not just talking about the disk is filling. I'm talking about differences in the way applications behave and interact with each other. So our real goal here at the end of the day is to bring this down market and make sure that every company can benefit from this to the extent that they want to. So with that said, I'm going to attempt to play a video here. This is a time warp because it takes a while to actually deploy these things. So I'm going to walk you through it. Ignore the clumsy UI here because this is just sort of the prototype front-end stuff. So here you've got some, security groups and key pairs and instance types and subnets. Very exciting, I know. You can see the form getting filled. Unfortunately, it's kind of cropping off the screen there. I don't know why that's the case. But so you'll see here we've got our subnet. We're going to go ahead and we're going to auto-discover. So all we've given it at this point is an Amazon account and a subnet that we're interested in. And by doing that, we have a provisioner process that will go in behind the scenes and launch a instance. You can see it's called auto discovery there. Chef is used on the instance to deploy, in this case, Xenos Core, which is an open source monitoring package that we have done a lot of work with over the years. And the idea here is simple. We have a basic configuration that tries to do as much as it can to auto discover everything it can about the environment, and then push that back up into our SaaS service. So again, think of how Meraki took the control plane for networking and moved that into a SaaS service. We are trying to take the control plane for monitoring, telemetry, alerting, analytics, all of that, and move that back up into the mothership so that companies don't have to run it unless they want to. And I'll get to that part in a minute. So You can see here, Chef is running, Xenos is running, trying to find things. And now, populated on the left here, we've discovered a bunch of assets. So there you can see that the auto-discovery instance was automatically terminated. We're building a big back-end API using swagger.io that will give users, customers, and our own tooling access. Again, think microservices. We're not trying to lock anybody into using our tooling, our scripting, our front end, whatever. We want to expose as much of this as possible to our customers so that they can repackage and reuse all of these components in the ways that make sense for their business. We're not trying to lock people into a specific monitoring tool or visualization tool or orchestration framework. We're just trying to give them the option, but not the obligation, of having these things deploy automatically for them and operated for them under contract if they wish, not required or expected. So now we've moved on to actually deploying the real thing. So here's Chef running. Once again, this time we are deploying a persistent instance that is going to run the Xenos core application and do data collection, alerting, thresholds, monitoring, visualization, what have you. And if at the end of this Chef run here, the client said, you guys are stupid, you're fired, that's fine. They can still keep all of the work that's been done to date because it's in their account, their environment, they have their credentials, and we have no further interest in it. We expect, by the way, to include far more than just Xenos in our suite of things that we will gladly deploy, wire up, connect, and SaaSify for you, but we also keep in mind this idea that at any point we should be expendable. We should not be mandatory for you to keep using any of this infrastructure because, after all, this is open source software and it is your environment. So now we have a bunch of devices here that are actively being monitored, and you can see they're already emitting tickets into Zendesk. This literally takes just minutes to wire up. Also wires into PagerDuty, wires into Slack, so you can get alerts and notifications. In this case, this is a managed services prototype customer, so you can see that the organization ID is there. You can log into the Xenos Core web app and see that it's already been pre-configured with all of your devices that you auto-discovered and whatever else. And again, these are the events that are generating tickets coming in right out of the gate. So without any human interaction or SNMP community strings or WinRM credentials or whatever else, we're able to tell you some things. And if you wait 20 minutes, which we're going to fast forward here, you'll also find that all of the telemetry we collect from Xenos and other sources, think CloudWatch, think your existing monitoring tools, think APM tools, gets fed into Elasticsearch, Logstash, and Kibana for visualization, analysis, and, you guessed it, predictive analytics and machine learning functions. So this is the general idea behind what we're building. We think this is the right approach, given that there's only so much you can do to forcibly colonize someone else's deployment, especially if the people aren't there to help you do it. And with that, all right. Well, if anybody's looking for me, here's how to get a hold of me, and happy to take any feedback or rotten vegetables. And I hope you guys have a great Chef conference. All right.